Okay, so what's going on here?
Kind of came out.
So here's
not very well.
ballistas, catapults,
Had to be hot.
we have an Ultimaker.
I'm not sure how to get.
So what do you throw with those catapults?
But I suppose if you turn the thermal gun,
Oh, cool. Can you show me?
Oh yeah, yeah. Was that like 400?
so that's a thermoplast.
Very nice.
So
Yeah. Yeah. I'll have some suggestions.
Woo!
No cap
Nice.
on. Of course, it's capped on tape.
And this
So those are.
It's a little expensive. Somebody said.
How do you build those? They are cut on a laser cutter.
Just using limited tin film. Plus, you can
so
get
this needs
a wood sheet cover the whole thing.
And you sell the kit.
yeah
To build them.
Kits for the catapult.
It probably gets
Fortunately,
available
not yet.
somewhere. They do slip those off the roll.
Even though I designed the ballistic.
Yeah. Really.
Cool. So go ahead.
Oh, so I copied this half and I turned that into the catapult. And this part is you can see it's essentially the
And
same.
it just raises the bed up.
I see.
Putting it out on here.
Although I probably should change this one since I have this piece to make it shoot higher.
That's very nice. Very neat. Thanks. Tell me what's going on here.
my name is Lisa Geertsen, and I'm one half of Firelight Forge. My husband Andy is the other half, and we are full-time artist blacksmiths. Some of
Blacksmith.
our artwork.
Actually, I was listening to a piece on NPR this
Wasn't
morning.
that wonderful? That was our
Yeah.
friend Mark.
Oh,
I'm
so you know this guy.
excited to hear it.
I guess you guys all know each other in the
A
area.
lot of us know each other.
Yeah. So how many blacksmiths are there in the United States nowadays?
Now the NPR lady had that answer for you. I don't know the whole country, but our club, the Northwest Blacksmith Association, which is Washington, Oregon, and Idaho, I think in Montana too, and Vancouver, British Columbia. We have a membership of over 500 people, some of which are hobbyists, some of which are, young people wanting to learn the craft, and quite a few are full-time.
Okay.
Like we do.
Full time. That's
Full-time.
nice.
This is our
That's
job.
awesome.
Architectural
Cool.
work, artistic work, whatever people need to have made.
Very nice.
Yeah.
Okay. Well.
And in a little bit, we're going to be forging over here at our little to-go station.
Wow.
Our real studio's in Georgetown, Seattle here.
Okay. Very nice. Hi. So what's going on here?
Hi, so this is Open Beam, and this is a construction system that we are making and selling.
Okay.
The system consists of these joining plates and these aluminum profiles.
Okay.
You put the nuts and screws in the joining plates, and you slide it together like so, and you tighten it, and you can build complicated structures like the trebuchet here, or this right here.
Very nice. So it's like Legos.
It's like Legos.
It's open source.
It's open source. The joining plates are around 95 cents a pop in retail. The bars, extruded 1 meter long, is $10. So
Nice.
it's a really low cost system aimed at the hobbyist market, and it's completely open source.
What's the coolest system that you've seen people build with that?
Well, we are actually still filling Kickstarter orders, so we haven't really seen a lot of stuff in the wild yet. But
Okay.
there are guys that are designing hologram printer setups,
Okay.
3D printers and laser scanners. So
Nice.
there will be some really interesting
So-
stuff being built with this.
Why is it important for this to be open source? What's the closed source alternative to this?
The closed source alternative is something like 80/20, right? Which is what the Microsoft guys over there are using on their robot.
Okay.
The nuts are 70 cents a pop.
How much?
70 cents per nut.
Whereas yours is.
Mine are hardware store nuts. They cost about a penny and a half a piece.
Okay.
And if you add up the cost of the Microsoft robot, the nuts and bolts actually would cost more than the bar.
So did you invent that, or are you reusing?
I'm the designer of the system.
Great.
This is my design.
Fabulous. Fantastic. Congratulations.
Thank you.
Good luck.
Thanks.
Hi.
Hi. Well, we're representing Ada's technical books, which is
Okay. So you have books about anti-pirate potato cannons.
yes.
So in case of pirate attack.
Yeah. That would
Okay. Do you have anything for zombies?
Not really,
Oh, you need to get stuff against zombies.
but I'm sure you could use some of the pirate.
You're also selling some kits here.
Yes.
So you have some
There's some
electroluminescent wire. Oh, Simon.
Yeah, the Simon game, the watch kit, this TV be gone kit there's already. At our
Cool.
store, at our physical location, we have lots and lots and lots of kits.
So where is your physical location?
It's in Capitol Hill,
Okay.
here in Seattle, on the north end.
Oh, Ada's Technical Books. That's the name.
It has technical books.
Okay. Ooh. Hi.
Hi.
What's your name?
David.
So what are you doing here?
So we run a camping event called Toorcamp.
Okay.
It's American Hacker Day.
Okay. So what are the structures here?
These are all geodesic domes that kids came over and they made out of marshmallows and toothpicks. We've been handing out these kits.
That's a great idea. So how do you start with one of those? What's the basic principle behind it?
Basically, all these start with the hexagon and a pentagon, and then it's just a bunch of other pentagons that are connected together. So even with much larger domes, it's all just hexagons and pentagons. It's kind of what Buckminster Fuller envisioned as being an ideal sort of tensile structure.
Cool. Very nice. And there are lots of buildings that are actually built this way. Yeah.
Yeah, like Epcot Center and Tacoma Dome.
Yeah. Very nice. Nice way to learn about geometry and structures.
Yeah.
Very nice.
So yeah, we're throwing a 5-day camping event
Oh.
on the Washington coast.
Oh, and then once you're done, you just put the marshmallows on the fire and eat them.
Yeah.
Cool.
So this is just to get people involved, get them
Very nice.
learning about new structures, and hopefully come out and build their own.
Very nice. Thank you. Hi. So what's your name?
My name's Brad Griffith.
Okay. So you're the what guy?
I'm the stick bending guy.
Stick bending guy. So you bend sticks.
Oh yeah, yardsticks.
Okay.
Popsicle sticks, tongue depressors, coffee stir sticks, yardsticks.
If it's wooden and if it's a stick, you bend it.
Oh yeah, and you know what? We also bend branches.
Oh.
So nothing is, I bend all sorts of stuff.
So how do you bend them? Do you wet them first and then let them dry?
Overnight or 2 nights and microwave 3 minutes.
Oh.
And then we have all sorts of different techniques to wrap it around something and let it dry in front of a house fan.
Okay.
And then it stays in that shape. Once you glue it up, spray varnish it. Don't varnish it a lot real fast because the sticks will absorb that moisture and they'll want to go back to the shape.
Very nice. So we've got the Space Needle here. What else do you have? Oh, you have a crane here.
We have a construction crane.
Yeah. Oh, exactly. I can't make
Lots and lots of stuff.
I can't make that one.
You want to get good.
Oh, so you do have wires.
It's the palm of my hand,
plus,
if I were to
negative.
it would be like wired to something.
That looks dangerous. I love it.
And a sander.
And the sander. Very nice.
So we make, toys. This is the new form of woodworking where we don't have to have the big boy cut, chop, saw, drill, sand tools from the garage. All this was made from our laundry room. And when we can put ribs in, and then you can skin it. You can make all sorts of toys.
Very nice. Thank you very much.
Yeah.
Hi, what's your name?
My name is Emmett Lalish.
So what do you do here?
I design things and print them on 3D printer. So
3D printers. That's awesome. So yeah, tell us about some of that stuff.
Alright, so these are almost all my designs. This is not, and this is not, but most of the rest of these are.
Oh, I have one of those, but not 3D printed.
Oh, really? Yeah.
Yeah.
It's a difficult puzzle.
Yeah, it's the most difficult puzzle in the world, right? Oh, and oh, I love those.
So this is probably one of my more popular things I've designed, the gear cube, and that evolved into, of course, the heart gears, kind of the same idea. And
what holds them together? What holds the pieces together?
well, on this one, this was one of the more original ones that they're screwed together.
Okay.
But on the more modern ones, it's all printed. So they have simply printed
springable nice.
So no glue, no nothing. Just printed.
So I've seen a lot of those online. Are you saying that you came up with that idea?
Yeah, I'm the designer. If you look on Thingiverse, they're up under my page. So I designed pretty much all of these, you know. This is a modification of some earlier designs on Thingiverse.
Show that again. I didn't have time. Nice.
So, just a fun little iris, you know. I enjoy mathematics, so this is a gyroid cube. You know, some little...
Oh, there we go.
Oh, I want to play with this one.
And of course, puzzles. I mean, you know, you gotta have your puzzles, so...
Nice. Hi, what's your name? What do you do?
Well, we're a student group from the University of Washington.
Okay.
We work on 3D printing.
You work on 3D printing?
We build printers. This is our new printer, the Grommet. It's a super small 3D printer. It's based derivative of the Wallace.
And it is printed. What? The printer is printed in a large part. And how much does it cost to build one of those?
It costs about $300.
That is super cheap.
Super cheap.
And
it's really small. They're very
what's controlling it here?
We're using a printer board with Splinter and Pronter face.
Fantastic.
Yeah.
$300. So where do I buy one of those?
It's not for sale yet.
It's not for sale yet.
Will be soon. Go to woodfreaky.org.
Okay, is it open source?
Yeah, it'll be open source. We'll put the files up soon.
Awesome.
Still fine-tuning a little bit.
Great.
Yeah.
Okay, so there is another thing here that is pretty big. I put my hand next to it to show how big it is. So what is this?
This is our first extruder model. We're going to be modifying it. It's an extruder. We're going to put on a modified plasma cutter.
Okay.
So we'll be able to print 4 feet by 8 feet by 3 feet build space.
How much is that in metric system?
Metrics.
1.25 meter by 1.25 meter by a meter.
By a couple meters by another meter.
Okay, so that is seriously awesome. It is huge.
This is the filament. This is our first try, which had a bunch of paper in it. It didn't work very well. This is our second try. This is milk jugs, ground up milk jugs.
Oh, so you actually build the filament yourself?
Yeah. Well, this will take shredded milk jugs directly.
Okay.
Into a hopper, and then this will be the bead, like the filament that comes out of here.
Okay.
That's what this will be on a big scale.
That is awesome. So you build everything.
Yeah. So this is our first. I just as I was extruding it, I just caught it on a piece of wood. But
so half of the printer is actually you.
Yeah. But it's really strong stuff. It's going to be difficult because the HDPE shrinks 2%. So we're going to have to do a lot of practicing to get it going.
It's engineering, lots of tweaking stuff. And okay, cool. Hi, what's your name?
My name is John Roper. I'm with the Magnicians.
So what is this thing?
This thing is an electromagnet, or it's a magnetic field visualizer. So it's basically 4 electromagnets suspended in water with nickel flake and some powerful LED lighting. Basically what we do is we take the water, the nickel flake is suspended and floating in the water, and we turn the magnets on, the little particles of nickel become coherent, and they line up, and it reflects the detail lighting out to you, the LED lighting that's in the top and the bottom.
So you can view the invisible.
Yes.
That's awesome.
Yeah, so basically you can see a magnetic field in 3D, and we're doing some stuff right now. We're going to hook it up to some music and your heartbeat in a minute, so you'll be able to like kind of visualize your heartbeat on them or whatever.
So what are you doing with this? Are you showing it to students in schools, or?
This is the first place we've ever shown it, so...
You need to show it to kids, to teach them about fields, and yeah, what is a field?
Yeah, you can really see what a magnetic.
Yeah, exactly. That's very interesting. I'm a doctor in physics, so I'm very excited about this. Awesome. Congratulations! This is really seriously awesome. I love it. Yeah. All right, thanks.
At the beginning of the day, by the end, and come back at like 5 when we're done.
Hey, what's the temperature?
Maybe 2 or 3 out of the gate. It's pretty. Well, okay, so you could probably build them pretty cheap. I blew so much electronics up in the process of making this that it was kind of expensive to get here. The other magnets, which if you turn on multiple magnets, you can see the interaction of the two fields together. So we can change the polarities around, we get some interesting effects. Like, tell me about the legs.
Yeah, it's not a computer simulation, it is physical. You really see what's going on.
Very organic.
Yeah, I love it. Let me turn around it a little so that they can see the 3D-ness of it.
Okay, and
this is
the second one is white and kind of a yellow.
Fantastic. What's your name? What do you do? What are those?
Our Xbot Robotics.
Okay, so you've got one of those here, and it has some crazy wheels here. So what are those called?
Those are called Magnum wheels.
Yeah. So what?
They allow the robot, without changing the robot's orientation, it can drive in any direction, any vector.
And when was that invented?
I'm not actually sure. It's been around for probably 10 or 15 years.
Yeah.
It was
so it's fairly recent.
It was first used on forklifts.
Okay.
Allowed to work in small warehouses put their stacks closer together.
Okay. So you've got some.
So the forklift didn't need the room to turn.
Oh. Okay. Yeah, you just
it can ride sideways.
It can just turn in right angles, just like that.
It doesn't have to do any turn.
Yeah, that's very interesting. Awesome. So, who do you build those for?
We are a 501c3.
Okay.
We are doing community outreach to students and schools.
Fantastic. So it's education mainly?
Yes.
That's great.
But we also rent space to anyone that needs a shop to work in.
Oh, nice. So are you around here, around Seattle?
In Skate Building.
Okay.
Chinatown.
Cool. Thanks a lot.
You're welcome.
Okay, so go ahead. Who are you?
Hi, my name is Dan Robbins, and this is the Magic Dollhouse, a modular architecture construction kit for kids and the young at heart. The kit consists of interchangeable modular rooms that can be moved around in lots of different ways, and then these add-on theme packs to give different appearances and different functionality. This is laser cut. Once a room is put together, it cannot be taken apart. There's no glue and there are no fasteners. This is a prototype, but I hope to take it to production. If you want to track the progress of this project, please go to its Facebook page, facebook.com/magicdollhouse.
Fantastic, thanks. Go ahead. Hi, how are you?
Great. This is the Microsoft Gadgeteer booth here. We have Lego electronics. Basically, you can take it apart, put just about anything you want to together. We've got a range of things. Some of the works are for the dome, we're still working on them.
So tell me about some of that stuff. That's a lot of stuff. A lot of modules you have here.
From CPUs to motor controllers. This one you can stick in your plant to see how wet it is. So you can build a robot that waters your plant for you. You can hook your computer up to the Ethernet and actually have a web server that's about the size of this. You can build your stuff on a board using something off the shelf. You can have yourself 3D made little blocks where you can fits in the box. Here we have a game. We take these into elementary schools as a kit. Kids put them together for in about 30 seconds. I'll say 30 minutes. Then they play for 3 hours.
So how you doing?
This is a simple analog input. The anemometer measures wind.
Nice.
So you can put together a sensor for about $40. So that's simple.
All right, so you guys are working for Microsoft, basically building fun stuff. That's your job.
Can be my job most of the time, especially if I come to work for free on the weekends.
Yeah, they're like that, I know.
Toys. I really do enjoy playing with all the toys.
Cool. Thanks. So who are you?
My name's Rusty Albert.
And what do you do?
I'm an industrial artist.
Okay. So you build apparently dangerous stuff out of metal. So it's...
I would say more that risk is a factor that's involved rather than danger. Think of it this way. Can you name a single activity in which you engage that you find interesting that also doesn't involve risk?
I love risk.
Segregate risk and fun, right?
Yeah.
So life is like sledding, basically.
Yeah, I agree with you.
Yeah.
I want to learn stuff until I die.
Right.
Yeah. So you didn't bring your plasma cutter?
I brought examples
of what you can do with it, yeah.
6,000 pound machine.
Yeah, it's kind of it's difficult to hold around, I suppose. So what is this thing here?
These are 3 Jacob's ladders that are insulated inside an amber or silicate tube.
Okay.
And then these panels are the control side for it.
Oh! I love the mad scientist switches on them. That is fantastic, I love it.
Thank you.
So I can make those work?
Well, as soon as I can make it work, I have to finish poking at the circuit.
Oh, okay, I see. It's gonna be awesome.
Thanks.
Cool. Cool, thanks a lot. Hi, what's your name?
Hi, I'm Lori.
What do you do here?
I'm with the Joy Guild. We have a creative reuse challenge.
Joy Guild, so it's a guild that deals with joy.
Yeah.
So anything that provides joy to people.
Yes.
That sounds amazing.
It's really fun.
So what exactly? How does this translate into stuff?
Sorry. Well, we've taken donations from an architectural firm, and they've provided interior materials as well as architectural scrap.
Okay.
And we use it to create something new. It could be art. We built something. They're building a birdhouse over here.
Okay.
Some people do dioramas. All kinds of different ideas, and it's just what your imagination wants to make.
So you provide material and you let people play and build stuff.
Yeah.
Can you give me an example of something amazing that people have built maybe yesterday or today?
This lovely young lady is building.
Yeah, that is.
She's making.
That is lovely.
A collage.
Very nice.
And over here they're building a birdhouse. And we've had everything from animals created to slingshots.
Oh, weapons
all
too.
All kinds of different creations.
As long as it brings joy.
Yeah.
Great, thanks. Of you, tell me what you do.
What I do? Well, I'm here at Jigsaw Renaissance. I'm on the board. We try to encourage people to be makers and create things, learn how to do things. We've got a soldering station here.
So it's, what is it? Is it a maker space?
Yes, it's a maker space here in Seattle. It's at the old INS building on Airport Way. Oh,
sorry.
Careful there.
Don't burn yourself.
Yeah, reach out and bite you if you're not careful. Anyway, that's what this is about here. It's a shame they keep turning the lights off.
Oh, that's fine. That camera has a.
We've had a lot of people buy the booth soldering kits. So we've got a couple kits here. That one over there is one I made.
Okay, what does it do?
fireflies. It waits until it gets dark, and then pretends to be 6 fireflies.
Oh, cool.
There's 3 different firefly species that blink out. And then over there we have a sound-activated LED necklace pendant, which is what this lady is soldering here.
Okay, cool. Hey. Hey. So this is by far the coolest thing on the show.
Yeah,
I have to say.
The life suit with They Shall Walk, the robotic suit for paralyzed people. So they
Okay, so not only is this an awesome piece of hardware, it's also, I mean, practical. So how many of those exist?
There's 20 so far.
20.
We're gearing up right now to manufacture 1,000 to ship off to hospitals.
1,000?
1,000.
So where are you going to ship those?
India and Nepal, and we hope eventually the FDA will give us permission to let paralyzed people in the United States to walk. But right now we have green light from the government of India and the government of Nepal. So we're very excited about helping paralyzed people walk.
It is very exciting. Well, cool.
I need to use my torso with this old and older.